Hello students. Again, our mathematics class, we're going to be looking at another topic, which is sequence. And we have our interactive content here that will serve as a guide for this class. Now, when you're talking about sequence, a sequence is a collection of terms arranged in a specific order when each term is obtained according to a rule. So for any given sequence, there must be a specific rule. Now we have an example here. Let's look at it. The first number here is 3. We call this first term. Why we have 5 and we have 7 afterward, 9 afterward, and it continues. So if you look at this, there is a rule that governs this arrangement. Now look at this. If you add 2 to the previous term, then it's going to give us the next term. And if you add 2 to 5, it's going to give us 7. Add 2 to 7 is going to give us 9. So the rule that governs this type of sequence is what? Addition of 2 to the previous term. And that leads us to another example we have here. Each numbers are in a given sequence is what we call term. And we can denote them as U1, U2. It's not compulsory it has to be U, but we are just denoting with U1, U2, U3, U4, and the nth term of a given sequence is called the nth term. So U1 is called first term, U2 is called second term, and until the third term is going to be U3, the fourth term U4, until when we get to UN. Now let's look at this example here. 2 here under this sequence is going to be U1, 4 is going to be U2, 6 is U3, 8 is U4, 10 is U5, 12 is U6, 14 is U7, and 16 is U8. Now, what governs this rule is just additions of 2. By the time you add 2 to 2, it gives us 4. Add 2 to 4, it gives us 6. Add 6 to 2, it gives 8. 2 plus 8 will give 10, and that's what made up that sequence. Now we have some formulas that we are going to be using under this. We call this arithmetic sequence. So we have a rule that we have to be governing. You look at this sequence. There is a specific rule that governs this sequence. Now they have 2 ways of describing this sequence. The first one is the term-to-term rule. That is what happens to the next term after the first term. Now let's look at this sequence. This is 12, this is 7, 12, 17, 22, and 27. So what happens for us to get 12? Then we have actually attempt a operation on 7 to give 12. So if you look at this type of sequence very well, but you must add 5 to 7 to give 12. So addition of 5 to 7 will give us 12. Addition of 5 to 12 will give 17. Addition of 5 to 17 gives 22. Addition of 5 to 22 gives 27. So the rule for this type of sequence is what? That implies that we have UN plus 5. That is, addition of 5 to the previous term gives the next term. Now let's look at the second term of the sequence that we have. We call it a formula for the next term of the sequence. That this type of rule link each term to its position in the sequence. So the nth term rule can be easily deduced by looking at the common difference of the sequence. Now let's have this sequence. What is the common difference? Common difference means what the rules that is being added or subtracted or multiplied to the previous term to give the next term. Now let's look at this. We have 12, 9, 6, 3, and we have 0. So for this to happen, there is something that has actually occurred. 12 becoming 9. That implies that we have what? A subtraction of 3. So by the time you subtract 3 from the previous term, it's going to give us the next term. 12 minus 3 gives 9. 9 minus 3 gives 6. 6 minus 3 gives what? 3. 3 minus 3 gives 0. So this type of term, we can follow it to be what? Minus 3n plus 15. Where our n is going to be from 1, 2, 3, 4, 5. So when you have 1 here, 1 multiplied by minus 3, that's minus 3. Now minus 3 plus 15 is going to give us what? 12. In the next few activities, we are going to be showing us another formula that we can actually use to get the term of our sequence. Now let's look at an activities here. We are supposed to arrange these rules. We have a sequence is given by the term to term rules. UN plus 1 will give us UN plus 3. So that implies that the previous term plus 3 will give us the next term. Now, for this type of sequence that we have here, the first term here is what? Is 0. So for us to get the next term, that implies that we are adding the previous term with 3 to give us the new term. So let's add and let's see. We have to generate U2, U3, U4, and okay. So U2 means the second term, U3 means the third term, and U4 means the fourth term. So U1 here is 0, and the rule for this sequence is n plus 1, which is UN plus 3. So when we have U1 here, we have U1 to be what? 0. So for us to get U2 is going to be what? 0 plus 3, and that is what? That is 3. Okay? U3 is going to be what? U2 plus 3. What is the answer for U2? That's 3. So it's going to be 3 plus 3. 3 plus 3 will give us what? 6. Okay, so U4 is going to be what? U3 plus 3 based on the rule. This is what we are following. So U3 plus 3 will give us U4. So what is the answer for U3? That is 6. Now 6 plus 3 will give us what? 9. And that gives us the term of that sequence. So let's drag and let's follow what we have already solved this here. So U1 is 0. So U2 is going to be U1 plus 3, which is what? 0 plus 3. 0 plus 3 will give us what? 0 plus 3 will give us 3. Now for U3, it's going to be U2 plus what? U2 plus 3, which is 3 plus 3. What is 3 plus 3? That is what? 6. Okay. Now for U4 is going to be what? U3 plus 3. What is U3 plus 3? That is what? 6 plus 3. 6 plus 3 will give us 9. And that is the solution to the problem. So let's check our arrangement. We are cool. Now let's look at another rule that we have here. Under this rule, I'm going to be giving us the formula that we are going to be using for arithmetic sequence to get nth term. So now this formula is what? Is going to be UN. We are denoting it as UN equals to A plus n minus 1 in brackets D. So we have UN equals to A plus n minus 1 into bracket D. This is the formula for arithmetic progression. We call it arithmetic progression or arithmetic sequence. Why is it arithmetic? Because under this we basically add or subtract. Now let's look at this given sequence. We want to look at the rules that govern this sequence. This is the first term, this is the second term, third term, the fourth term, and that. So this formula that we have here, A is the first term. We make A to be the first term, A is our first term, and D is the common difference. What do we mean by common difference? The rule that govern that sequence. Let's study this rule. For us to have 7 to be U2, then that implies that we must have subtract 5 from what? From 12. So when we have 12 minus 5, it's going to give us 7. So the common difference for this sequence is going to be minus 5. Because by the time you subtract 5 from the you have 7. So now we are under that. What is our first term? Our first term is what? 12. So we are going to be using that formula to get our n term. So UN is going to be 12 plus, we don't know n, right? We are looking for n minus 1, and D is what? Minus 5. So let's multiply minus 5 with what we have inside this bracket. It's going to be 12 plus minus 5, okay, minus 5n minus 5. Minus 5 times minus 1 will give us what? Plus 5. Okay, now let's open the bracket. We have 12 plus minus will give us minus 5 and plus 5. So we are collecting the like and bring 5 to the other side. We have 12 plus 5 minus 5 n. Now, okay, so 12 plus 5 is what? That's 17. So 17 minus 5 n. Remember, we are having UN equals to 17 minus 5 n. So this is the rule that governs this sequence. So quickly, let's just check. When n is 1, let's see if we are going to have 12 here. When n is 1, let's check for U1. So let's put 1 to at the back of n here. That is 5 minus 5 times 1. That is what? 5. So 17 minus 5 will give us what? 12. And that is the rule for that sequence. Now that leads us to the next slide that we have here. And let's look at the next activity. Okay, under this we are having exponential sequence. So exponential sequence is a sequence of number in which the ratio between the consecutive terms is constant. So when you're talking about exponential sequence, we are trying to look at ratio here. So it's either we multiply in this type of sequence or we divide. So, and we can also call this type of sequence a geometric sequence. So the rule here, we call it what? We call it common ratio. A common ratio is the amount between each number in a given sequence. So amount is the between each number in a given geometric sequence is what we call common ratio. And we can denote it as R. Okay, so we have it as R. And with that, we are going to be looking at an activity here that says we should look at this rule. Let's look at this. This is a term-to-term rule under exponential sequence rule. So let's study this first one. This sequence, the rule that governs this sequence is what? Is multiplication of 2. So by the time you multiply 2 to the first term, it will give us the next term. 3 times 2 is what? 6. 6 times 2 will give us 12. 12 times 2 will give us 24. So the rule that governs that sequence is what? 2un. So that what we mean by that is that when we are multiplying 2 with the previous term. And this one, by the time you look at this, the rule that governs this one is a multiplication of 2 to the previous term to give the next term. So under this one, we can say that generally the rule is un equals to ar raised to power n minus 1, where our a is our first term. Now under exponential sequence or geometric sequence, r is the common ratio. So that's the general formulas for calculating exponential sequence or a geometric sequence. Now we have application of the exponential sequence. Let's look at this example, and we are going to be solving the example together. Okay, Alex deposits $1,500 in his savings account. The interest rate offered by the savings account is 4% each year for a period of 10 years. Assuming Alex leaves the money in the account, calculate how much interest he has gained after 10 years. Now, under this, we have to use our exponential rule, which is un equals to ARN minus 1. But note, under this one, we are actually looking like something on we are looking at calculating the interest per year. So our n year is going to be representing the year for which Alex actually saved 1,500 in his savings account. So A is going to be the first term. What is the first term? The principal, which he actually saved inside his account for 10 years. And R is going to be what? The rate at which he got the interest over 10 years period. And N is going to be the numbers of years he actually saved the money to get the interest. So we are going to be having it to be UN, where N is going to be 10. A is what? $1,500, and we have R to be saved percent. So for us to get R, you know we are rating in percent. So R is going to be what? 106 over 100. 106 over 100 is what? That is 1.06. 1.06. Okay. Now let's come here. We have A to be 1,500. Remember, we are rating in dollars. This is telling us that we have a multiplication sign in between it, and our R is 1.06. We have rated it under percentage. Our N is what? N is 10. Now, what we need to do here is what? We multiply all of this together. So we have U then equals to $1,500 multiplied by 1.06 raised to power 10. So 1.06 in 10 places multiplied by 1,500 is going to give us 2,686.27. Remember, we are rating in dollar. Now, for us to get the amount of interest, we have to subtract the amount after 10 years from the starting capital, which is 1,500. So we are going to be having 2,686.27 minus 1,500 in dollars. So we are rating in dollar. So by the time we subtract that, we are going to be having 1,186.27, and that is the interest over 10 years that Alex used to say that amount. That leads us to the past question we have here. We have to find the next term of this sequence, and we have to find the nth term of the sequence. The sequence is 22, the second term is 17, third term is 12, the fourth term is 7, and the fifth term is 2. So let's look at this. By the time you look at this type of sequence, okay, this type of sequence, if you study it, we are subtracting 27 from 22 from 17. So let's study what we have here to give us the next sequence. So we have 22 minus 17. What would that be? If we subtract 22 minus 17, and we will be able to get the next sequence. So 22 minus 17, 22 minus 17, the sequence is 22, 17, 12, 7, and 2. So we want to know the rules that govern this sequence. 22 minus 17, that is what? That is 5. So for us to get 17, that implies that we have to subtract what from the the previous sequence. We have to subtract 5. So the common difference here is going to be what? Minus 5. So to get the next two terms, then we have to bring in 2 minus 5. 2 minus 5. What is 2 minus 5? That is what? Minus 3. That's the next term. To get the next one is going to be minus 3 minus 5. So minus 3 minus 5 is what? That is minus 8. Okay, that's the solution to the A part. The B part said that we should look for the n term. So let's use the formula that we have under arithmetic sequence, which is un equals to a plus n minus 1 into bracket d. Our a is the first term, d is the common difference. Under this sequence, a is 22, which is the first term, and the common difference is what? Minus 5. So we have 22 plus n minus 1. That is what we are looking for. We are looking for the n term, then minus 5. Let's multiply this by minus 5. What we have in the bracket, so we have 22 plus n times minus 5 will give us minus 5. Okay, so we have minus 5n. Now minus times minus will give us plus. 1 times 5 will give us 5. Now let's open the brackets. Plus minus will give us what? Minus. So we have minus 5n plus 5. un equals to we are rearranging 22 plus 5 minus 5n. 22 plus 5 is what? 27 minus 5n, and that is the rule that governs the sequence. So let's quickly see and let's check if we have the first term to be what? 1. Okay, so 1 multiplied by 5 minus 22 minus 27 will give us what? That will give us 22. Now let's look at the next slide we have. So for the next slide, we have another past question here. These are the first 4 terms of a sequence. We have 1, 23, 45, and 67. We have to write down the next 2 sequence, and then we should look for the n term. So we are going to be writing down the next 2. Let's deduce. If you look at this sequence, what makes this sequence is difference of what? Addition of 22. So if we have 1 plus 22, it will give us the next term, which is 23. 23 plus 22 will give 45. 45 plus 22 will give 67. So to get the next 2 terms, it's going to be what? 67 plus 22, which is what? 89. The next one is what? 89 plus 22, which is what? 111. And that is the next 2 terms. Now we want to get the n term. We are going to be using our formula, which is un equals to a plus n minus 1 into bracket d. A is what? A is 1. A is the one which is the first term. N here we don't know. We don't have n. And our d is what? Our d is 22, which is the common difference. So now we have 1 plus 22 multiplied by n will give us 22n. Minus 1 multiplied by 22 will give us minus 22. Now let's open the bracket. 1 plus 22n minus 22. Now we are bringing in, we are rearranging this. We have 22n minus 22 plus 1. So it's going to be 22n minus 21. So that is the rule that governs the sequence 22n minus 21. Let's look at the next slide and let's see what we have there. We have another past question. We have to find the first three terms of that sequence, and we have to find the n term. So let's check the first three terms of that sequence. We have n squared plus 7. So when n is 1, that is the first term. N is 1. We are going to be having to be n squared plus 7. 1 squared plus 7. What is 1 squared? 1 squared is 1. So 1 plus 7 will give us what? Will give us 8. Okay. For the second term, it's going to be 2 squared plus 7. What is 2 raised to power 2? 2 raised to power 2 is 4. So 4 plus 7 will give us what? That is going to be 11. Okay. The third term is going to be what? 3 squared plus 7. What is 3 squared? That is 3 times 3, which is 9. 9 plus 7, that is 16. And that is the first three term of that sequence. Now, let's look for the nth term of this given sequence. We have 15, 7, minus 1, and minus 9. Now, let's study this together. What is the common difference? Let's look at the first and the second term. 15 and 7. For us to get 15, for us to get 7 from 15, we have to subtract 15 from 7. So 15 minus 7 will give us minus 8. So subtracting 15 from 8 we give what? We give 7. So the common difference of this sequence is what? Minus 8. So with that, we are using un equals 8 plus n minus 1 into bracket d, where our a is the first term, which is 15, plus our n, we don't know, we are looking for the n term, and our common difference is what? Minus 8. So we have 15 plus, let's multiply minus 8 with what we have in the bracket, which is n minus 1. Minus 8 multiplied by minus, multiplied by n will give us 8 minus 8n. Minus times minus will give us plus. 1 times 8 will give us 8. So let's open the bracket and let's try to rearrange so that we can get our un. So we have it to be 15 plus plus times minus is minus 8n plus 8. So we are bringing the like terms together. We have 15 plus 8 minus 8n. What is 15 plus 8? 15 plus 8 will give us what? It will give us 23. So 23 minus 8n, and that is the rule for that sequence. This takes us to the end of this class. I want you to subscribe to our channel www.edubbey.com for the full interactive content of this class. Thanks for listening.